the topic environmental pollution and its control strategies. Okay, you all aware of the pollution. It's a very common word nowadays. Using everywhere, we are using this term pollution. Everywhere you can see the pollution. It is not a new term, and you're already aware of the pollution, isn't it? So today I'm going to speak on the various aspects of pollution, such as water pollution, air pollution, and land pollution. So just to give the definition, pollution is the introduction of harmful substances or products into the environment, such as water, air, and land. So that is called pollution. So you can see some of the pictures I would like to show you the extent of pollution we are doing in the environment to the environment. You can see that some pictures where water is polluted with the releasing of various toxic pollutants to the environment. You can see how the water bodies and water seashores and water bodies are polluted with the various pollutants. So let's see what are the causes of water pollution. Taking example, the factors that contribute to the water pollution can be categorized into different groups. So it can be broadly classified into two types. One is point source of pollution, another one is non-point source of pollution. Now, point source of pollution is the source that can be easiest to identify and control that source, whereas the non-point sources are ambiguously defined and ordered to control. So that is the difference between the point source of pollution and non-point source of pollution. So I'll give you some of the examples for point source of pollution. Waste from the factories, waste from sewages, from power plants, or underground coal mines, water from oil wells, etc. They are called as point source of, because they are direct source of water pollution and can be reduced and monitored. So that's why they are called as the point source of pollution. Whereas non-point source of pollution is the term, the source encompasses a large range of sources, such as when rain or snow moves through the ground and picks up pollutants as it moves towards a major water bodies. So that is called non-point source. For example, the runoff of fertilizer from the farm animals and croplands, air pollution getting washed on deposited on the earth, stormwater drainage from lawns, parking lots, and streets. So these are all these examples for non-point source of water pollution. So I'll just show you some of the pictures of non-point source where this water is coming from the coming and carrying all the pollutants along with that water. So that cannot be identified with a point, but it is contain a lot of pollutants in that. Some of the pictures I would like to show you that regarding the air pollution. So air pollution is one of the important nowadays. So because of the burning of fossil fuel, you all know very well that what extent we are using the fossil fuel and releasing the various compounds into the environment, particularly air. So you can see some of the things. So let's see what are the sources of air pollution also. So one of the main causes of air pollution is the release of carbon dioxide into the atmosphere. This happens because of the deforestation and fossil fuel burning. And sulfur dioxide is another air pollutant and is released into the atmosphere by burning of sulfur containing compounds. And sulfur in the atmosphere is responsible for acid rain. So these are all the things which you already know. And chlorofluoro, in addition to that, CFCs are also contribute to the major source of pollutant. And the burning of plastics, another important problem is the burning of plastics everywhere. You can see that the plastic is burned in particularly rural area along with the solid waste. They also burn this plastic and releases various compounds, particularly dioxins, into the atmosphere. So that is a important source of air pollution. In addition to that, The natural air pollution also takes place by smoke from wildfires, methane released from livestock, and volcanic eruptions also contribute to the air pollution, in addition to the man-made or anthropogenic activities which are causing the air pollution. So you know the consequences of air pollution. I need not explain in detail. It leads to the global warming. How this global warming happening is because the carbon dioxide, a good transmitter of sunlight, but it is also a partially restricts infrared radiation going back from the Earth into the space. That's why which produces the so-called greenhouse effect, and that effect that prevents a drastic cooling of the Earth during the night. So that is called as greenhouse effect or global warming. Increasing the amount of carbon dioxide in the atmosphere reinforces this effect and expected to result in a warming of the Earth's surface. That is called as global warming. The consequences of air pollution is the global warming. So how this global warming takes place, you know already. So that means the oxides, carbon dioxide, particularly released into the atmosphere, is not allowing the infrared rays or the heat trapped on the surface of the earth go. It should go back to the atmosphere. It is trapped around the globe in the atmosphere, and as a result, the increase in the temperature taking place. So that is about the air pollution. Let us see some of the things about the land pollution. So you can see that everywhere we are dumping our waste, solid waste, or whatever the waste we are produced after the use, we are dumping everywhere. And you can see in some pictures, just a sample of pictures I want to show you. And like that, there are so many things which are causing land pollution. You can see that causes of land pollution: construction waste, agriculture waste, domestic waste, industrial waste. These are all contribute to the air land pollution because of the undiscriminate throwing and disposal of the solid waste on the land. Construction waste also nowadays, everywhere you can see the construction urbanization. Because of urbanization, we can see that everywhere the construction is taking place, and the waste produced during the construction activities are dumped on the land, which is indiscriminately without taking any precautionary measures. The buildings take up resources on land. The trees are chopped down and used to make buildings, takes away from places or animals and other organisms to live. That is the causes of this land pollution, particularly construction activity. So even including agriculture activity, also one of the major contributor of soil pollution, land pollution, particularly, as there are more and more people are inhabiting in the earth because increasing population, food is in the higher demand. So in order to produce the food, and so forests are chopped down and turned into farmlands. In addition, the herbicides, pesticides, and artificial fertilizers, animal manure are washed into the soil. So particularly nowadays, you can see in the agricultural lands, the farmers are using herbicides, weedicides to kill the weeds in the field. So because of the labor cost, so their easy application of herbicide is cheaper and easy to remove the weeds on the crops in the crop fields, weeds and herbs. So they are applying these herbicides indiscriminately without knowing their effect on the soil. So that is one of the important pollution nowadays taking place in the particularly by agricultural activities. If you go to rural area nowadays, everybody is using the herbicides in order to kill the weeds or weedicides. So in addition to that, our domestic waste contribute to the land pollution. Tons of domestic waste is dumped onto the every day. Some of the waste from homes, offers, and industries can be recycled or burnt in incinerator. You know, every year, every day, a person is producing nearly half a kg of solid waste every day, and it is disposed indiscriminately. So that causes and there is still a lot of garbage, such as refrigerator and washing machines, that are dumped in landfills simply because they cannot be reused and anyway, nor recycled. So in such the extent of the land pollution we are causing. So in addition to that, the industrial waste also contribute to the land pollution. Plastic factories, chemical plants, oil refineries, nuclear waste, disposal activity, large animal farms, coal-fired power plants, metal production factories. So you can give hundreds of examples that of the industries which are causing the land pollution. You know, land pollution, consequences of land pollution already. The land pollution exterminate the wildlife, which affect the wildlife because they lead that pollutants. Acid rains that kills trees and other plants. The vegetation that provides the food and shelter is destroyed. Land pollution can seriously disrupt the balance of nature, and in extreme cases can cause human fatalities. Pesticides can damage crops, kill vegetation, and poison birds, animals, fishes. Most pesticides kill or damage life forms other than those intended to kill. That is, non-target organisms also killed by the pesticides. For example, pesticides used in an effort to control or destroy undesirable vegetation and insects often destroy birds and small animals. Some life forms develop immunity to the pesticide used to destroy them. So that is these are the consequences of land pollution. So I would like to give some examples. The pollutants which are contributing are released into the environment, particularly naturally occurring compounds in the environment that are present in unnaturally high concentrations, such as xenobiotic, that are man-made compounds, chemically synthesized compounds, and that have never occurred in the nature or released into the environment. Example, pesticides, herbicides, plastics, and even crude oil, refined oil, phosphates, heavy metals. These are all the compounds which are directly causing environmental pollution. So, in addition to that, some hazardous pollutants. You can see what are hazardous pollutants. The misplaced chemicals that causes harmful effects in environment. They are called hazardous pollutants. Like they are very toxic to the human beings and the animals. They are poisonous, carcinogenic, that can cause cancer, mutagenic, they can cause the mutation in the chromosome and causes various genetic abnormalities in the human beings. Teratogenic, even the birth defects are caused by these various pollutants, and some of them are flammable, that means they can catch fire easily, and corrosive, explosive, endocrine disruptors like that. These are some of the harmful effects of the pollutants which are released into the environment, to the water, soil, or air, whatever it may be. They causes the hazardous pollution, hazards in human beings. So you can see some of the other example compounds like PCE, TCE, and most common groundwater pollutants used. These are all some of the oil spills, coal tar. These are all the examples, common pollutants. Like heavy metals also, some heavy metals, mercury, lead, cadmium, chromium, and polysaccharide, polychlorinated biphenyls. They are all the examples of the common pollutants. So this in this chart, you can see some of the example table common pollutants in the environment which are causing which are very much of a seriously causing environmental pollution. Sources of contamination also already told you: industrial spills, surface compounds, storage tanks, pipes, landfills, burial areas and dumps, injection wells. These are all can causes the industrial spills and leaks. Surface components, storage tanks and pipes are also contribute to the environmental pollution. So in this picture, you can see that how they can causes the pollution. So this is about just the brief about the pollution, either water pollution, soil pollution, or air pollution. So their sources and their effect. I have not touched upon the health effects of these pollutions, but you know already what are the important health problems caused by these various pollutants released into the environment. Now let us see the control aspects or the conventional methods of remediation. So we are causing pollution. So we know that, but what we do, we have to control that or remediate that. So, in order to that, what are the methods available in order to control this pollution or reduce the pollution or prevent the pollution? Let us see one by one. So, in the conventional methods or in what we are following is either dig up and remove it to a landfill. What we are doing is dig up and remove it to a landfill. We are doing. There are cap and contain. That means maintain in the same land but isolated. So that is the things we are doing. So let us see what is the risk of excavation, handling, and transport of hazardous material is very expensive to find another land to finally dispose this material. So dig up and remove it is a very difficult. And cap and contain also can see only an interim solution. Cap and contain method is also an interim solution. Requires monitoring and maintenance of isolation barriers for a long time. So these are the conventional methods we are following. But products are not converted into harmless products these days. So what we are doing earlier was this dig up and remove it and landfill and cap and contain method. So products that are the pollutants are not converted into harmless products, but they remain as such without any change. So that is the problem of this. So let us see, is there any better approaches? Can we any approach better methods are available to solve this environmental pollution problems? So there are many approaches are there. So let us see one by one. Yes, what are the better approaches? What we can do? Either destroy them completely, possible. You can destroy the pollutants completely, possible, or either you can transform them into an harmless substance. So these are the two approaches we can do in order to control the pollution or remediation of pollution. Either we have to destroy the pollutants completely, or if it is possible, or transform them into harmless substance. So how to do this? Let us see. So method already using. So to destroy, what we are doing is methods already use are the high temperature incineration. So by burning the pollutants, highly toxic pollutants, is by high temperature, that is called incineration, or chemical decomposition like dechlorination, immediate oxidation. Like that, we can completely destroy that the pollution pollutants. So that method already which we are using doing. So what are they effective? So what we are doing is either destroying them completely, or we can transform them into harmless substance by various methods, by chemical methods or whatever the methods available. Is sufficient? But are they effective? We have to think about that. So yes, we are doing, but they are effective, but only to some extent. So you can burn the hazardous waste, but cannot completely burn or cannot completely destroy them. Okay, so we can, to some extent only we can do this, achieve this. So what are the drawbacks of this conventional practicing methods? There are so many drawbacks. Let's see one by one. So for those methods, we need technological complexity. The cost for small scale application, you cannot apply for small scale application. Lack of public acceptance, especially incineration, burning of waste, cannot be accepted by the public, because if you burn that waste, so it also leads to another problem, that is air pollution or some other compounds. For example, incineration generates sometimes more toxic compounds. If you can destroy one compound and it will release another compound. Materials released from the imperfect incineration causes undesirable imbalance in the atmosphere. Example, ozone depletion. Fall back on the earth and pollute some other environment. But particularly dioxin production due to burning of plastics leads to cancer. So these are the major drawbacks of this burning or incineration method. So let us see what is the alternative for this. These are what I explained are the either chemical process or physical process methods which are used for the control of pollutions or pollutants in the environment. So they, you know that what they are not the not enough or good enough. They indirectly they also causes another type of pollutions. So what is the next alternative? What is the possible way which we can overcome this problem? Is, let's see, the bioremediation. So bioremediation is a makes effective, better possible approach. So I will tell you what is bioremediation now. It is either by destroying or rendering them harmless using natural biological activity. You know what is bioremediation? Bioremediation is a solution or remedy to control the environmental pollution by either by destroying or rendering the harmless destroying or render them harmless substances released into the environment using natural biological activity. That is called as bioremediation. Let us see what is the definition. I tell you is the use of living organism to transform, destroy, or immobilize the contaminants. That is the definition of bioremediation. The ultimate goal of this bioremediation is to detoxification of the parent compounds or the pollutants and conversion into products that are no longer hazardous to human health and environment. So that is the ultimate goal of this bioremediation. So here you can see that this picture, the contaminant is converted into non-toxic end products by the action of by using microorganisms or the living things, use of organisms, either it may be plants, or animals, or microorganisms. So that is called as bioremediation. So what needs to be cleaned up? It can be applicable, it can do this bioremediation by to the soil, water, air, and sediments also. Pollutants enter not in many way already, different way I told you already regarding the pollution. So location of accidents, amounts of chemicals released. So these are the things which you already know. So the bioremediation is the how you can do that. I'll tell you one by one. Okay. So this bioremediation process or application is broadly classified into two types. One is in situ bioremediation, another one is ex situ bioremediation. So that means bioremediation which takes place on site where the pollution has been occurred. There itself we can do that this process, apply this process. That is called as in situ bioremediation. Whereas ex situ bioremediation is the process of bioremediation, application of bioremediation from somewhere else. We can take up that pollutants and treat it somewhere else. That is called ex situ bioremediation. So these are the two types broadly. And in situ bioremediation, again, there are different methods are there, like bioventing, in situ biodegradation, biostimulation, biosparging, bioaugmentation, natural attenuation. Like that, in the ex situ bioremediation also, there are different methods like land farming, composting, biofuels, bioreactor. These are the different methods are in the in situ and ex situ. Let's go one by one how they can be done. So in addition to that, if you use the plant material for this process of remediation of the pollutants, that is called as phytoremediation. Use of plants, various plant species are known for the used for this process. They are called as it's called phytoremediation. Again, in phytoremediation, there are different methods are there. Phytoextraction is there. I will tell you later what is phytoextraction, phytodegradation, phytotransformation, phytostabilization, rhizome degradation, rhizofiltration, like that. You can see the different methods. If you use the microorganisms, it is microbial bioremediation. If you use the plant, it's called phytoremediation. So like that, depending on the type of living organism used, we can classify into different types. Let us see one by one, taking the in situ bioremediation. What is in situ bioremediation? I told you already. So we are going to perform this activity in the place where the pollution has been occurred. Okay. So, for example, what are different methods includes bio-venting. Venting means opening, providing the way. One of the most common approach in the soil treatment. If the soil is polluted with some compounds, so we can do this process. Supply of air and nutrients via wells is called, and takes advantage of indigenous microorganisms. What we are going to do is we are providing the oxygen as well as the nutrients to the soil where the microorganisms are already present, that is indigenous microorganisms. Okay, so these microorganisms are able to degrade these pollutants, so that is why it is called as bio-venting. In situ biodegradation also, the supply of air and nutrients by circulating aqueous solution through the contaminated soil or groundwater, that is called in situ biodegradation. And biosparging means injection of air below the water table that increases groundwater oxygen concentration and mixing in the saturated zones. So that is called as the biosparging. And bioaugmentation is the addition of indigenous or exogenous, in addition to the indigenous microorganisms, that means which are present already in the soil or water where. So we are going to apply the other microorganisms which are isolated from some other place, some other isolates to that. Okay. So in addition to that, biostimulation is there. Naturally also it will take place, that is called natural attenuation or intrinsic bioremediation. So here in the picture, I would like to show you how this process is done using these various bioventing. Is a process of stimulating the natural in situ biodegradation of contaminants in a soil by providing air, oxygen to existing soil microorganisms. In this picture, you can see that oxygen is the most commonly supplied through the direct air injection into the residual contaminants in the soil, in addition to degradation of adsorbed fuel residuals, volatile compounds are biodegraded as various vapors moves slowly through the biological activity of the soil. So we can see that how this vacuum, so they are provided air to the ground or water or the soil where the pollution has taken place. So here you can see biosparging means, sparging is additional injection if needed or injected into the saturated zone to increase the biological activity of the indigenous microorganisms. Biosparging can be used to reduce the concentration of petroleum constituents that are dissolved in groundwater, absorbed to the soil below the water table and within the capillary range. So we can see that vacuum pumps and compressor and nutrient for the nutrient feed also. So this is the schematic diagram how this process can be done. So naturally also it will, degradation takes place using biodegradable capacity of indigenous microorganisms without additional enhancement. So without any additional, so naturally also it can be takes place. That's called as natural attenuation. Feasible only when biological degradation rate is faster than the rate of contaminant migration. So that is also possible. So there are the steps into the, what are the steps which we have to follow during this process. We have to investigate. First we have to investigate the site where the pollution has been taken place, whether it can be treated or not. We have to study treatability studies, recovery of free products and removal of the source, design and implementation of the in situ bioremediation system, monitoring and performance evaluations. All these are the steps involved. So like that, ex situ bioremediation is the one which you can take place which outside the polluted place. So like, for example, there are different methods like land farming. Land farming is a contaminated soil is excavated and spread over land. Soil is periodically tilted to improve the aeration. Remediation due to indigenous microorganisms as well as chemical and physical process, generally limited to the superficial 10 to 35 centimeter of soil, can reduce the monitoring and maintenance of cost. Another method is the composting. You know, composting is a very common method. It's an example for the ex situ bioremediation. method. So it combines contaminated soil with non-hazardous organic amendments like manure or agriculture waste. For that, we can do this composting process. Biofiles the biophiles are the combination of land farming and composting together. It's called biophile. And then in addition to that, bioreactors are used. You know what is bioreactor? Bioreactor is an engineered structure or the fabricated structure where you can control various environmental factors or like temperature, humidity, soil, moisture, uh, various concentration, microorganisms, everything can be controlled. It is a fabricated structure or engineered structure where you can perform this biodegradation process by controlling various physicochemical parameters. So soil and water pumped from the contaminated plume and source through the engineered containment system. It is called, that's why I call engineered containment system. So degradation in a bio is generally greater than in situ bio because the contained environment is more controllable and predictable. So you can what is the required environment for the degradation of particular compound can be provided in these bioreactors. So these are one of the most effective way of controlling the doing this bioremediation process using bioreactors. So here you can see some of the examples of ex situ bioremediation. You can see containing soil excavated, containing soil is excavated and treated in number ways. See here you can see this is the small structure of bioreactor, slurry bioreactor, where the maximum contaminated soil with hydrogen peroxide plus stimulate. So you can see that. See here also the schematic diagrams of composting. You can see like vermicomposting also, soil and heavy other bulking agents are mixed together. So land farming can spread the pollutants in a land, barren lands, which is not productive lands. So biofuels are also used. So like that, you can see this is a schematic representation. So you can see land farming, how contaminated soil is excavated and spread over land. So soil is periodically tilted to improve aeration. Remediation is due to indigenous microorganisms as well as chemicals, physical process, generally limited to the superficial 30 to 35 centimeter of soil. So you can see that composting, I need not tell about detail about composting. You know that composting is one of the best way of reducing the soil pollution, particularly organic waste are uh, used for this composting process. Okay. More recently, composting has been investigated as a remediation technology for hazardous waste also. Even hazardous waste are also used for the for composting. Okay. Then you can see biofuels system offer the potential for cost-effective treatment of contaminated soil. Like composting, biofuels provides favorable environment for indigenous microorganisms to degrade contaminants present in the soil. So these are some of the examples of bioreactors, where bioreactors, different types of bioreactors are there, depending on the type of pollutants which we are going to use. So they are designed the various types of bioreactors. For example, a slurry bioreactor is defined as a containment vessel and apparatus used to create a three phases, solid, liquid, and gas mixing condition to hasten the biodegradation of soil-bound and water-soluble contamination as a water slurry for contaminated soil, sediments, sludge, and biomass. Usually, indigenous bacteria capable of degrading targeted contaminants are used. So that is the advantage of the slurry bioreactor. Slurry is in a liquid phase. So these are some of the advantages of slurry bioreactor. Bioremediation, enhanced process control, faster rate of biodegradation, better physical contaminant. So this, you can see that advantages. So there are different types again. Fixed biofilm bioreactors are there. That is, fixed film bioreactors have become conventional technology for treating biodegradable contaminants in air and water. So here, principal fixed film reactor application includes treatment of industrial wastewater, leachate of groundwater, and air emissions, of volatile organic compounds, etc. In the reactors, biological activity usually converts contaminants to innocuous and end products such as carbon dioxide, methane, and water. So this is the example for fixed film bioreactors. So like that, another advancement in the bioreactor is the suspended growth bioreactors also use a little bit advanced technology. Suspended growth bioreactors are standard technology for treating organic contaminants in aqueous and waste flood systems. The reactors use microbial metabolism under anaerobic or sequential aerobic and anaerobic condition to biospore organic pollutants and biodegrade them into noxious compounds. So like that. It's okay. So let us see how this, whether the bioremediation is effectiveness of the bioremediation process, feasibility of bioremediation process. So it depends on three factors. One is the microorganisms, what type of microorganism is used, what is the potential of that microorganism is used. So that is very important. And environmental factors, I told you the most important environmental factors which are contribute to the successful bioremediation is the pH, redox potential, temperature, moisture, nutrients. These are all the very important factors which contribute to the successful or effectiveness of the bioremediation. In addition to the contaminant type and state, also very important. Contaminant type means what type of contaminant can be used for this process. All types of contaminants cannot be treated by the bioremediation method. That is the most disadvantage of this bioremediation. Only biodegradable compounds can be degraded by these subjects, and also state of that contaminant also is very important, whether in which state, liquid, solid, or gaseous state. So that is also very important for the success of this process. I would like to give some of the examples of these microorganisms particularly used for this bioremediation process. Includes aerobic bacteria like Pseudomonas alcagens, Spingomonas, Rhodococcus, and Microbacterium are commonly used for this degrade the pesticides and hydrocarbons, alkanes, and polyaromatics. Many may be able to use the contaminant as a sole source of carbon. How they do that process is these microorganisms use this compound or the contaminant as a sole carbon source. And in addition to that, aerobic bacteria, there are some other bacteria like methanotropes. Like aerobic bacteria utilizes the methane for carbon and energy. They are called methanotropes. So methane monoxygenase is a broad substrate range. That is here, the enzyme which is involved in this process is called methane monoxygenase. It's an enzyme produced by the methanotropes. So they are active against wide range of compounds. Example, chlorinated aliphatic such as trichloroethane and 1,2-dichloroethane. And in addition to this aerobic and methanotropes, anaerobic bacteria are also used in this process. Not used as frequently as aerobic, but they're also used in this process. Anaerobic bacteria are also used frequently. Fungi are also used. Some of the fungi are also used for this process, able to degrade diverse range of persistent or toxic environmental pollutants. So let us come to the mechanism of this bioremediation, how these microorganisms perform this process, the degradation process. Let us see. The contaminant may serve as the primary substrate to the microorganisms or secondary substrate to the microorganism or act as a co-metabolic substrate to the microorganism. So they use the primary substrate, they use enough available to the sole energy source, whereas in the secondary, as a secondary metabolite provides energy not available in high enough concentration. As a co-metabolic substrate, purchase transformation of compounds by microbes relying on some other primary substrates. So this is the chemical reaction which takes place. Requirement for microbial growth are the electron acceptor, okay, and toxicant that is as a carbon source, and environmental factors, nutrients. So these are the requirement for the microbial growth in the polluted for the bioremediation. So here also electron exchange which takes place in here, electron acceptor like oxygen, O2, NO3, SO4, etc. and carbon energy source electron donors are so like finally water and carbon dioxide released from these compounds. So you can see both aerobic versus anaerobic process also. So aerobic process, if oxygen is the thermal electron acceptor, the process is called aerobic biodegradation. So whereas all the biological degradation processes are classified as anaerobic biodegradation. In most cases, bacteria can only use the thermal electron acceptor. Facultative aerobes use oxygen but can switch to nitrate in the absence of oxygen. So here are some of the example. So aerobic versus anaerobic oxidation co-metabolism. Okay, so these are the example for insecticides, aliphatic aromatic compound, where it is used as co-metabolism. Some example I would like to give you, like for example, benzene is an important pollutant which is degraded by the various microorganisms. Okay, some xenobiotic compounds also, I will not go in detail about that. Okay. Factors affecting technology degradation, substrate specificity, electron acceptors, other nutrients, temperatures, I already explained about you. Okay. I will not go in details, as the same examples. Some of the microorganisms involved in the biodegradation of these xenobiotic compounds. You know what is xenobiotic compound? Anybody can tell about what is xenobiotic compound? Okay, so these are the compounds which are man-made, synthetic compounds. These compounds are also degraded by various microorganisms, Acrobacter, alkalogens, Azotobacter, Pseudomonas, Putida, Candida. So like that, there are various microorganisms are used to degrade the xenobiotic compounds also. Like even E. coli, alkaline Pseudomonas aeruginosa, are used to degrade the organic pollutants like hydrocarbons, surfactants. So pesticides also degraded by Pseudomonas aeruginosa, Pseudomonas sphaericus, 2,4-D, Anthracobacter. Like that, you can parathion is degraded by the Pseudomonas species, and E. coli, Pseudomonas aeruginosa is also used for the degradation process. So here, genetic regulation of genetic, so some of the plasmids bond compounds are used as substrates also. So some of the assay to system biodegradability test, how to test that, whether that compound is biodegraded or not. So there is a test or assays are also, they are called as biodegradability test. Measurement of oxygen consumption by manometric and electrolytic system is also used for the to test the biodegradability. Okay, and measurement of carbon dioxide evolution by infrared or chemical methods also used. Use of radio-labeled substrates, measurement of the disappearance of chemicals by GC, gas chromatography, determination of the reduction of DOC, chemical biodegradability under the aerobic conditions, measurement of, okay, like that. There are the methods which are used to confirm whether that compound is degraded or not. So that is called confirmation test. So even genetically modified microorganisms are also used in the way back in 1970 itself. The isolates of Pseudomonas putida, a genetically modified Pseudomonas putida, is used for the treatment of the oil spill, degradation of oil. Contains plasmid that encode genes for the breaking down the pollutants. They are used. That is a genetically modified bacteria. So E. coli also genetically modified E. coli is also used. Okay, and to degrade the heavy metal, particularly heavy metals, copper, lead, cadmium, chromium, and mercury. These are the compounds which are degraded by the genetically modified E. coli. So you can see that how they do that genetic engineering is taking place. So these are the environmental factors I already explained. Required environmental condition for degradation. Those parameters like soil moisture, pH, oxygen, temperature, etc. Condition required for microbial activity and optimum values for degradation. So in this table, you can see, taking examples, what is the requirement for this degradation of compounds. I have already explained. These are regarding the microorganisms. The use of microorganisms for the degradation of process or bioremediation. Let us come to the phytoremediation. Phytoremediation means I already explained you. The use of plants for the degradation of pollutants is called phytoremediation. So here also you can see different methods of phytoremediation, like for example, phytoextraction or phytoaccumulation. So here plant used to accumulate the contaminant in the root above ground biomass like root, stem or flower, whatever. So in the above ground level, so the plant, the pollutants are accumulated. So that is called phytoaccumulation, and this accumulated compound can be extracted by various methods. That is called phytoextraction. Phytotransformation or phytodegradation is another method in this the plant can perform is uptake of contaminants and transformation to move to more stable, less toxic or less mobile forms by the plant species. That is called phytotransformation. They will transform the uh, uh, compounds present in the soil to the uh, to different forms or other forms which are less toxic to the environment. And phytostabilization is another way where the plant species uh, perform this. That is, mobility and migration of contaminants are reduced through the sorption into the plant. So rhizodegradation is breaking down of contaminants through the activity of the rhizosphere. That is called rhizodegradation. Rhizo means roots. Roots play a very important role in the degradation process. They absorb the pollutants and store in that roots. That is called rhizostabilization or rhizodegradation. Rhizofiltration also. Roots are also used as a water remediation technology used to reduce contamination in natural wetlands and estuaries areas. Okay, so these are the example of phytoremediation. I'll give you the schematic diagram how this process will takes place. Okay, so here you can see the root system also. You can see how the pollutants accumulates in the leaf system and in the photovolatilization. The compound absorbed by the plant is volatile into the evaporated into the environment. That is also there. So these are all the process which take place in the plant species. So here you can see that how the schematic representation of phytoremediation. Phytoextraction means if the pollutant is accumulated in the leaf can be extracted. Volatile, the compound which will escape from this leaf, and phytodegradation also takes place. That means compound is converted to some other compound which is less toxic, and even the phytostabilization, they are present in the root. So this is a schematic diagram which shows the phytoremediation. So non-biological remediation technologies and phytoremediation are not mutually exclusive. Okay. Examples: heavy metals which are herbicides, mercury, heavy metals. They are all used for this process. Non-biological remediation also technology. Okay. So advantages. What are the advantages of this pollutants? Or the cost-effective, natural method, minimal land disturbance, reduce potential transport of contaminants by wind, reduce erosion, Hyperaccumulators of contaminants means much smaller volume of toxic waste. Multiple contaminants can be removed with the same plant. So that is the advantages of this phytoremediation. Disadvantages are also there. Slow rate of and difficult to achieve acceptable levels of decontamination, potential phase of transfer of contaminant, possibility of contaminated plant entering into the food chain, possible spread of contaminant. So these are some of the disadvantages of the phytoremediations. Okay, decrease in the action during the winter. So trees and plants require care. Contaminant high might kill the tree. Also, sometimes the plant itself be killed. Much testing is needed before procedure can be utilized. So examples I'll give you. Okay, one of the best examples, successful story is the bioaccumulation of arsenic. The 20th, it is the most important element. Okay, so it is in India. In India, the Bangladesh, the 400 million people have the risk of arsenic poisoning, and up to 40 million people drink well water containing the toxic level of arsenic. So that is a major problem in Bangladesh. So it is uh, uh, degraded by the use of this very important plant species, that is using Arabidopsis, genetically modified Arabidopsis engineered plant is hyperaccumulator of arsenic. Okay, bacterial arsenic reduces the catalyzed reduction of arsenic to arsenite that will convert the pollutant into non-hazardous compounds. Okay, bacterial reduced arsenate can be bind organic thiols such as those in the then transformed to vacuoles. That means in the plant species, this is going to be accumulate. Okay, so just a picture I want to show you. This is a test which are conducted to confirm the process. Some of the plant species I want to show you. The Teres, which is used, Teres vittata is very commonly used for the degradation. It is considered as the hyperaccumulator of arsenic. Used to 1500 micrograms arsenic per gram and can be accumulate up to 23 milligrams per gram. Okay, so it's the best example, a very good plant species for the degradation of arsenic contamination. So some of the plant species which are used for this process, okay, you can see that the metal derived, how much it can be degraded or reduced, converted, is remediate some of the plant species, Acornia, Thalapsi, Minucheria. Like that, you can see various plant species which are commonly used for this process. Even water hyacinth is very common plant species which is used for this phytoremediation. Okay, and lemma, duckweed is also used for this process. So like that, you can see various plant species which are used for this phytoremediation of rhizofiltration using Ornododonax, another intensive root system in this plant used for this bioremediation. So like that, you can see even for the remediation of saline soils using Salicornia, pickleweed, which accumulate the salt. So like that, you can see various things which are already explained. Various. There are some advantages of this process. What are the advantages of? So bioremediation is a natural process and is therefore perceived by the public. Is useful for complete destruction of wide variety of contaminants. Instead of transforming them contaminant from one environmental medium to another, for example, from land to water or air, the complete destruction targets pollutant is possible. So like that, there are so many advantages also. There are some disadvantages also. Is limited to those compounds that are biodegradable. Not all compounds are susceptible to the rapid and complete degradation. There are some concerns that products of biodegradation may be more persistent or toxic than the parent compound. Okay, like that, there are other disadvantages also. That various not instantaneous, often need to develop system. may have inhibitants present. Compounds may not be biodegradable from polymers, plastics, like that. So it's some of the successful stories of bioremediation. That is case studies of bioremediation is the Exxon vessel does oil spills, that is cleaned up the oil pollution by that company. Okay, by South Central Alaska oil spill, one of the most example for success story of this bioremediation. Okay, so these are the just I'll show you when it started in 1989. This Kings Island. So this bioremediation project was taken up. They got a very positive result. Okay, based on the promising result, they got recovery of valuable metal. Conclusion, I would like to conclude by bioremediation is a simple natural process which is less expensive than other technologies that are used for the cleanup of hazardous waste. Bioremediation can often be carried out on site, often without causing major disruption of the normal activities. It is an environmental friendly approach. So that is my conclusion.